Today we have two learning goals. We want to divide polynomials, and we want to be able to do that using long division and something that is called synthetic division. So long division you learned back in elementary school, I don't know, 3rd grade maybe, but just to refresh your memory, because most people don't long division on a daily basis because they use a calculator, I just want to do a problem real quick here to review how long division worked. So let's say that you had 6,250 and you wanted to long divide that by 21. What you did is you asked yourself how many times 21 went into 6, which is none. 21 doesn't go into 6. So then you asked yourself, how many times does 21 go into 62? Well, 21 goes into 62 almost 3 times, but not quite. It only goes in twice. So you put a 2 up here, and then you took the 2 that was up here and you multiplied it times what was in front. 2 times 21 is 42. Then you subtracted, so minus, so that gave you 20. And then you brought down the next number. And then you repeated the process. And you said, how many times does 21 go into 205? So, to make 21 go into 205, it goes in almost 10 times, because 10 times 21 would be 210. So it's just a little short of 10, so it's a 9. It goes in 9 times. So then you take the 9 times the 21 and write it underneath, which is 189. Then you subtract again. So 205 minus 189 gives you 16. And then you brought down the next number again. So 160. So then you ask yourself, how many times does 21 go into 160? Well, almost 8, because 20 times 8 is 160. So this is a little short. It goes in 7 times. 7 times 21 gives you 147. So 160 minus 147 is 13. And there were no more numbers to bring down, but since it didn't come out evenly, you learned to add zeros, bring the next thing down, repeat the process, and this became the next thing. Or in 3rd grade, if you didn't learn how to do that, before you learned that, you said, well, 21 doesn't go into 13, so that's my remainder. Remainder 13 was another way that they taught you to do it. So, polynomial long division is set up the exact same way as regular long division is. We're going to put whatever we're dividing by on the left side. That's called the divisor. So here the divisor was 21. Down here, my divisor is x squared minus 1. So I'm going to put the divisor on the left side. Make sure you leave just enough room at the top to write your numbers on the top and letters. The dividend has to go on the inside. That's what you're dividing into, the first one. Notice there must be a term for every exponent. So that means if you're missing a degree, you have to enter a 0 as a placeholder. Now here, my highest exponent is 3, so I start there. I do have an exponent of 2, so that's good. I also have an exponent of x to the first, that's this term, and then my 3. So I wasn't missing any degrees here, I had everything. So we're going to follow the exact same process we would for long division with numbers, except it's with variables. So you're just going to ask yourself, you're going to look at just the left part, the first term of the divisor, and ask yourself, what do I have to multiply x squared by to get negative x cubed? So if I want the exponent to go up by 1, I need to multiply by x, and if I want it to become negative, it needs to be negative x. Here's the key. As soon as you have the answer to that, so we figured out we need to multiply by negative x, you have to make sure you put it over top of wherever its like term would be. So here's the plain x terms, that's where you record this. Now, as soon as you write something on top, it's exactly the same as what we did here. After you wrote something on top, you multiplied it times the divisor. So we're going to do that. Negative x times x squared is negative x cubed. Then, because there's two terms here, negative x times negative 1 is positive x. Notice that I'm lining them up under their like terms. After you multiplied up here, we subtracted. When you subtract polynomials, remember you distribute the negative and then add. So the way I do this is I change the signs. So I make this a plus, I make this a minus, and I circle them to let myself know that I remembered to change the sign. And now I can add them together. So negative x cubed plus x cubed, those cancel. There was nothing here, but I have to add it to the 2x squared. 2x squared plus 0 is 2x squared. And then negative 2x plus negative x is negative 3x. After we subtracted up here, look at the arrow, we brought down the next term. So we'll do the same thing here. And now we repeat the process. So we say, what do I multiply x squared by to get 2x squared? So I multiply by 2. So that goes up here. Now I do the multiplication. 2 times x squared is 2x squared. 2 times negative 1 is negative 2. After I multiply, I subtract, so that means change the signs and add. So change the sign, and now add straight down. So these cancel. This gives you negative 3x, and this gives you 5. Then you go back, say, what do I multiply x squared by to get negative 3x? Well, I can't, because x squared's exponent is bigger than this exponent. So once you get to that point, that means this is your remainder. Now, the way you write the remainder is by writing it, and it says it right up here. The remaining number or polynomial is the remainder and should be written as a fraction over the divisor. So that means you just add a little plus here. We're writing it as a fraction. So this, that's my remainder, over the divisor, which is x squared minus 1. So our answer, remember, is up here. So that's the answer right here. When I divide this polynomial by x squared minus 1, I get negative x plus 2 plus my remainder of negative 3x plus 5 over x squared minus 1. All right, takes a couple tries for this to make sense. So again, you've got to practice these. And that's why we do classwork on it too, to practice it again. So I'm going to set this up, and then I'm going to have you try to do the division on your own. So when we set it up, this is what I'm dividing by, so that's what goes over here. So y squared minus y plus 1. And then I'm dividing this. I start with a y to the 4th. So my next term needs to be y to the 3rd. I don't have a y to the 3rd. Again, look up here. Make sure to enter zeros for any missing degrees. So I need to write plus 0y cubed because it has to go down in order. Everything gets messed up if you don't have a placeholder for missing degrees. So after cubes are squared, so I have 2x squared there, or y squared rather. Then y to the 1st, that's this term, so negative y, and then my plus 5. So now I'm going to do the same thing. I'm going to say, what do I multiply y squared by to get y to the 4th? And then I'm going to continue. So you try to divide this, follow the whole process, pause it, come back and check. So with my starting, what do I multiply y squared by to get y to the fourth? I multiply by y squared. Again, remember to line it up on top of its like term. That helps tell you when you're ready for your remainder because you're out of space. So now, after I write something up here, I multiply. Y squared times y squared is y to the fourth. Y squared times negative y is negative y cubed. Y squared times 1 is y squared. After I multiply, I change the signs and add. So make this a minus, make this a plus, make this a minus, and now add straight down. So y to the fourth plus negative y to the fourth, those cancel. 0y cubed plus y cubed is y cubed. 2y squared plus negative y squared is positive 1y squared. And then bring down the next term. Now repeat the process. What do I multiply y squared by to get y cubed? I multiply it by y. So now multiply. Y times y squared is y cubed. Y times negative y is negative y squared. Y times 1 is y. Now I need to change the signs. So minus, plus, minus, and add straight down. These cancel. This gives me 2y squared. This gives me negative 2y. And then I bring down the next term. Oops, I forgot the plus sign. There we go. Now again, what do I multiply y squared by to get 2y squared? I multiply by 2. So I put a 2 here. 2 times y squared is 2y squared. 2 times negative y is negative 2y. 2 times 1 is 2. Now I need to change all the signs. So minus, plus, minus, and add. These cancel. These cancel. 5 plus negative 2 is 3. There's nothing else to bring down. There's nothing I can multiply y squared by to get 3. This is my remainder. So remember, we always write remainders as a fraction over top of whatever you were dividing by. So y squared minus y plus 1. All right. Now, your hand probably hurts a little bit, mine does, because it's a lot of writing, but hopefully it's not too hard. You're just using your exponent rules, subtracting, multiplying, all that good stuff. So, we can now divide polynomials using long division. Second learning goal is to divide polynomials using synthetic division. I'm sure that sounds really weird because you've never done synthetic division before. Synthetic division comes out of what's called the remainder theorem, which is why that's the title of this section. And the remainder theorem sounds fancy. It says if a polynomial f of x is divided by x minus k, then the remainder is equal to f of k, meaning if you plug in whatever this number is to the function, whatever you get is what the remainder would be if you divide them. So, you don't need to understand that fancy language. What you do need to understand is that that means that if I use my coefficients and plug that in, I am going to get my remainder. So this process means that we can actually just use the coefficients. So I can lose all of the x squareds, x cubes, all of that, and only work with numbers, which for a lot of people, only working with numbers makes things a lot easier. Now here's the catch. We can only use synthetic division when we're dividing by something in the form x minus k, meaning this term has to be linear. So these ones that we had up here, we can't use synthetic division for them because they have an x squared or a y squared. We can only use synthetic division when we're dividing by something that's linear. So x minus 2, x plus 5 is the only things that synthetic division will work for. Now, I've set up kind of a little cheat sheet for how it's going to look when you set it up, but the instructions are typed out here. You're going to set up whatever your value of k is. That number is going to go inside a box. So you're going to draw a little box, you're going to draw a line here, and you're going to put the k value inside this box. It says coefficients here. You take the coefficients of the thing you are dividing. So you are taking the coefficients of the dividend. So here, I've got x cubed minus 3x squared minus 7x plus 6. Those coefficients, it's 1x cubed, negative 3x squared, negative 7x, positive 6. The coefficients there are 1, negative 3, negative 7, 6. Those numbers you're going to put in a top row. So I'm going to go ahead and illustrate this with the example because just the words doesn't usually make a lot of sense until we see it in action. So in your box goes your k value. And remember, the form is x minus k, which means you're changing the sign to get the actual k. So if this is minus 4, that means you put a positive 4 in your box. So 4 goes in my box. The coefficients of what I'm dividing goes in the top row. They have to be in order. Again, in order, and I put in here, remember to enter zeros for any missing degrees, just like we did up here. So I've got x cubed is the biggest one. My x squared coefficient is negative 3. My plain x coefficient is negative 7. And my constant is 6. So I didn't have any missing degrees. I don't need to add any zeros. Then you're going to draw yourself a line. And I should have done this in the form. You're also going to have a dashed vertical line separating just the last number. And we'll talk about that here in a second. Here's what you're going to do. Right here. Bring the leading coefficient down below the line. That's why I have the arrow here, because this is always going to get an arrow. You bring the leading coefficient down below the line. Then multiply the box value by the leading coefficient. So box times leading, and put it under the second coefficient. 4 times 1 is 4. I put it underneath that next coefficient. Now add the column. Negative 3 plus 4 is 1. Now repeat the process. Box times the bottom gives me 4. Then add negative 3. Box times the bottom gives me negative 12. Then add gives me negative 6. The numbers in the bottom row are going to be the coefficients of our answer. The reason I draw this vertical dashed line is because the last number is going to be your remainder. Now, you can't just write this for the answer because this is a shortcut for long division. You have to put the letters back in. So, if these are the coefficients of my answer, I know that if I'm dividing an x cubed term by a plain x term, that this is going to be x squared. So whatever your original degree is, when you go to your answer, it should be decreasing by 1. So this represents 1x squared. This represents 1x. This represents minus 3 because x to the 0 isn't really there. And then this is your remainder. Remember that we write remainders just like in long division. You take whatever the number was, so in this case negative 6, and you put it over top of whatever you were dividing by, so x minus 4. Now, I know that probably still seems confusing for most of you, so I'm going to do another one, and I think it will hopefully make some sense. If not, we're going to practice some more, so after the classwork, hopefully you get there. Okay, so first thing I need to do is set up my box and the number that goes in it. I change this sign. So that means I'm going to put -3 in my box. Next, I need the coefficients of this in my top row. So x cubed is my highest exponent. Its coefficient is a 1. After x cubed should come x squared. And there is no x squared, which means I need a 0 there. After x squared comes plain x's. Its coefficient is -8. And after plain x's comes plain old numbers. So there's my 3. Draw my dashed vertical line. Draw my horizontal line. And when I start this, I always do the arrow down because I bring down my first coefficient. So now, multiply. -3 times +1 is -3. Then add. Then multiply again. -3 times -3 is +9. Then add this column. Gives me 1. -3 times +1 is -3. And then add, which gives me 0. My answer, again, if I started with x cubed, that means this is the coefficient of x squared. So 1x squared minus 3x plus 1. If the remainder is 0, that means it comes out evenly. So you don't have to write the remainder because there isn't one here. And so that is my final answer. And that is it. We now know 2 ways to divide polynomials. We can check that off. Long division, synthetic division. And that is it for today.